Thank you, Farah. So, I believe that we should let planetary boundary science influence the way we design buildings. I think that by going out to planetary scale and then working back, we can set the right priorities for building design and, more importantly, make a cost-effective contribution to solving these planetary environmental challenges. Now, in a nutshell, that means to say yes to large, off-site virtuous energy, and it also means to say no to on-site Eco-Bling. Now, planetary environmental science is obviously a really complex topic, and there are lots of different ways at looking at the problems that we face at a planetary level. But I think a piece of work that was published in Nature magazine back in 2009, titled Planetary Boundaries, is a really good summary to work with. Now, this piece of work, put together by 28 Earth system scientists, sets out 10 areas of impact. Now, I'll just run through this very quickly. There are sort of 5 areas where we're under the limits, and you can see we're encroaching the size of planet Earth there on those 5. But climate change, which I'm sure you're all very aware of, we're exceeding the recommended limit of 350 parts per million. Now, less known, we're also exceeding by a factor of 4 the nitrogen cycle capturing for fertilizers. And more concerning, we're exceeding a recommended limit for biodiversity loss by at least a factor of 10. Now, there are 2 items here that they've identified, aerosol loading and pollution, where they can't set practical limits. The scientists speak of tens of thousands of chemicals that have a negative impacts, and it's very difficult to quantify. It's obviously really important that we tread cautiously in this area and use less chemicals where we can. If you want to learn more about this, the lead author, Johan Rockström's done a TED Talk which summarises it, and also Mark Linus has written a book which summarises the science and then goes further and makes some recommendations for how we can solve these issues. Now, staying under these boundaries is obviously a complex issue, but I think we can stay under them by addressing 4 key areas of human impact. The first is air pollution. You'd see on screen this is a giant factory that turns tar into oil, which is one of the sources of petroleum used in our vehicles. It has huge pollution problems up into the atmosphere. Now, water pollution is a really complex topic. It's not just related to energy, it's also related to farming. This is an image of the dead zone caused by the water catchment across the whole of America from all the farms running fertilizers down into the Gulf of Mexico each year. Now, land use expansion is really about farming and about forestry. It's not about cities getting larger, really. Cities are a tiny percentage of our footprint on the planet. And finally, ecosystem destruction. This is the one that's, for me, most upsetting. And that it's on land, obviously expansion into the Arctic, into the Amazon, for instance, but also in the oceans, we're destroying ecosystems at an incredible rate. This is an image of bycatch caught up in tuna fishing, which is then just dumped dead back into the sea because it doesn't have the value of the tuna. Now, looking at these 4 problem areas, there are clear, large-scale solutions. So for air pollution, we need to clean up factories, farming, and obviously our energy system. Water pollution, we have to clean up mining, farming, and factories, and look to do a lot more water purification, as you can see on this image here. With land use expansion, it's a tough one because the solution for land use expansion is to densify farming, densify forestry. But when you do that, you create water stress issues and pollution issues. This image here, it's an area about the size of London, totally covered in glass houses in the southern corner of Spain. while that's a really efficient food production process, it causes pollution and water stress issues in a very water-stressed area of Europe. And finally, ecosystem destruction. We need to set limits. We need to avoid going out into places like the Arctic or the Amazon, leave some of nature there, and change the way we fish. The Maldivian fishermen catch tuna without bycatch, and we could be doing more of that. So, listening to what I've said so far, a lot of people would say this is just environmentalism gone mad. This is believing in nature as a sort of ideal that we need to respect and we need to treasure. And while I have to admit that I am an environmentalist, and I do like the planetary boundaries science in part because I do have that motive response to the environment that's so well portrayed in this artwork here. But that's not what the planetary boundaries science is about. The planetary boundaries science is about limiting human impact so that societies can thrive and continue. And also, importantly, avoid collapse. And Jared Diamond wrote a wonderful book looking back at past societies and how they collapsed, and lots of them were for exceeding the environmental limits. The image on screen here is one of the Easter Island, where a community cut down every last tree to build all these statues to remember their ancestors, and their whole society ended up collapsing. Now, there are other people who would say, if it's social problems we're trying to resolve, we need to defer environmental issues for the future, because as long as we've got more money in the future, everything will be okay. Our children, because they'll be much richer than us, can decide what they want to do about climate change, for instance. For now, we've just got to focus on more corporate growth so we can get cumulative economic growth. Now, I'd just like to dwell on that idea for a minute, using an example of a corporation who's had really impressive growth statistics. Not naming any names, this company, founded in 1886, produced about 1,000 litres that year. And then since then, they've had an impressive average growth rate in production of soda of 16%. Now that brings them to today, producing 200 billion litres of soda each year. And that's about 90 litres per person for all 7 billion of us. And so obviously, that can't go on for too much longer. You'd think there'd be a hard limit. Now, if we just ignored that hard limit of customers to sell the soda to and just kept going with this ambition of 16% per year, where would we end up in just 100 more years? Well, in 100 years from now, a volume of all the fresh water available on the planet would have to pass through the factories every year. And if we continued for 200 years from now, would it be all the inaccessible groundwater or the volume of the oceans themselves? Well, in 200 years from now, what's striking is with this 16% growth rate, we would need to have a ball of water the size of planet Earth pass through their factories. And of course you'd say, well, 16% growth, well, we don't need that, we just need 3. 3's fine. Well, 3% growth rate in production would still result in a ball of water the size of the planet Earth in just 1,500 years. Now, what's clear is that we can't rely on continued expansion to solve our problems in the future. We need to face them now and really consider the limits that are there. And what we don't want to do is leave the limits to be met naturally. We need to rely on the scientific community to help set limits for us. And that's where the planetary boundaries are so good, in my opinion. Now, so far, I haven't said anything about buildings. And, we're all building professionals, so what should buildings be doing to solve these epic problems? Now, there are those who believe that buildings can solve all of our problems. This is a scheme for a new city near Shenzhen in China that's literally had the whole farm thrown at a series of skyscrapers. Now, what I find really frustrating about this sort of scheme is it just ignores fundamental constraints. I can see some of the structural engineers looking a little bit sceptical in the audience. But for me, it's also really important to think about the energy. You know, the ambition of this building is to provide all the food for the people in these towers from within the towers. So they've got this ambition of a sort of self-sufficient tower that can save humanity, some sort of survival ambition. Now, how would the plants grow? Would they get their energy from the little wind turbines that were on top? Or would they just get the energy, which is more likely, from cheap coal-fired power? Which, of course, if they did do that, they might even be cost competitive with regular farming. But in a sustainable future, we would need to go to renewable energy, and it would need to be in the countryside. So if we had a huge solar array sending electricity to those towers, the electricity would be only a percentage of the sunlight would be captured, so 20% captured by the panels, and then grow lights are not as good as sunlight at growing plants. So the key point here is if we just scrapped the towers and put a farm out in the countryside, 1/10 of the area of those solar panels, you could grow the same amount of food. Now, looking at these schemes, I really just don't know how they're so celebrated and encouraged. And thankfully, our friend George Monbiot has taken the time to lay out all the numbers in an article in The Guardian in 2010, aptly titled Towering Lunacy. So if you want to learn more, you can look that up. Now, going back to this point that I just raised before about why people might celebrate this sort of futuristic ambition. And I think it's because self-sufficiency is upheld as a valuable idea for its own sake. You know, it's seen as a good thing to be able to survive, to close in. And while that's an honourable response to a dangerous situation for an individual, it's not a good thing for society. Because it's actually specialisation and cooperation between different people that has served us so well for the last 50,000 years. Now, I'd go further and say that if we uphold the self-sufficiency ideal and keep pushing it to its logical conclusion, we just all end up as simple subsistence farming, which is, while it was very exciting in the 60s in Texas, it's not something I think we'd all aspire to be doing. Now, coming back from these grand ambitions for new cities in China back to the UK, I think that this sort of self-sufficiency ideal underpins a lot of our thinking for the future. The Code for Sustainable Homes is an example of where we're setting carbon neutral as an ambition that treats each building as an energy island. Now, while this was a really interesting exercise in achieving that aim, I think projects like Kingspan Lighthouse have really just shown that we can't replicate that across all our buildings. We want taller buildings, and there wouldn't be enough roof space to get enough energy for taller buildings. And also, more importantly, the cumulative cost of all of these little energy islands is much greater than if we look at a systems approach. Now, this point of cost, O.V.E. Arup believed that cost was really important for design. Recently, Nigel Tonks has made a lot of his thinking accessible to all of us in this new book, Philosophy of Design. And reading it, I was really struck, on the one hand, by O.V.'s points about resource conservation and the environment such a long time ago. But more importantly, I was really impressed by the number of times that he mentioned cost as a key issue for good design. And I think that sustainable buildings need to consider that. Money is a limited resource, and we need to try and get the most value, the most environmental value for every pound spent. Now, it's not just our aspirations for the future, like the Code for Sustainable Homes Level 6, where these ideas are being pushed forward. There's also the current on-site renewable obligation that's imposed by the authorities in London. Now, the on-site renewable obligation costs a lot of money to achieve. And there's one example, for instance, where the on-site renewable obligation is achieved by using wood to produce combined cooling, heating and power. Now the cooling element is achieved through absorption chillers. Absorption chillers are very inefficient and they only make sense if you've got real waste heat. And wood isn't waste heat because wood is a limited resource. Now if you took that same wood, sent it to an efficient power station, sent the electricity back and used a regular chiller, you could get the same cooling for half the amount of wood. Now, this is really important because wood is a limited resource. And a recent study by the Committee for Climate Change for the government laid out sort of a strategy for biomass in the UK. And they suggest that no more than 15% of our current energy demands can be met with biomass. Now, they also go further to say that this resource should be prioritised. This report, though, is very focused on energy as a topic. But I think we need to go broader than that and think about all of the other uses that we want from biomass. You know, as Adrian Campbell so eloquently explained last month, we really need to think about building more in timber, and obviously we want high-value products like furniture. And so I would say that from an energy point of view, biomass should be reserved for rural heating where it can be done very close to the source of wood. Now, another example where a lot of resources and money has gone in to achieving the on-site renewable obligation. Now this tower in Elephant Castle has got 3 little wind turbines, and even if they operated as designed, which I believe they haven't yet, they would cost 100 times more per kilowatt hour generated than large offshore wind. It's not 10 times, literally 100 times more expensive. Now, why were they installed? Well, my understanding is the building was allowed to be taller on the basis that it was performing on energy terms very well. And so we have this sort of perverse incentive of doing something that's visually striking, but doesn't actually help our energy story. Now, I think we're missing a trick here in the UK because we actually have in the UK the best wind resource in Europe. And the way the energy markets are moving, they're all becoming liberalised and they're connecting to Europe. And so in the future, if we had a liberalised energy market and it was connected to Europe, we could sell wind power really cost competitively to European countries because the wind in the UK is expected to be cost competitive with gas by 2020, whereas in Spain, for instance, it will still be 2 or 3 times that cost because of the fact that they just don't have the same wind resource that we have. So, listening to what I've said so far, I've said that all of our environmental problems are solved outside of cities. We shouldn't be wasting money on all of these micro energy systems. And so really, it looks like we've got buildings that we can just get on as building professionals and we don't have to worry about it. You know, buildings get off scot-free. Maybe if we really feel like it, we could, sign up for a renewable energy tariff, or we could be careful about where we get our materials from, a bit more timber. Now, I think that view shirks responsibility. We've got to consider the secondary impacts of all of these big environmental problems that we're facing. So in the first instance, from an energy point of view, while we get the majority of our energy from fossil fuels, currently it's about 80%, it's an absolute imperative that we save energy. And that applies to everyone, but of course to building designers and building operators. And also, while our materials come from polluting factories, it's not good enough to just select materials that are clean or use sustainably sourced timber. We also need to design for material efficiency. Now, For those of you familiar with LEED and BREEAM, you might say, well, all of this has been well covered. You know, this is what these rating systems do. Well, I don't think that's the case, and the issue is the devil is in the detail, as always. These rating systems encourage on-site renewables and oblige companies to spend a lot of money on on-site renewables, and they also don't encourage material efficiency. The material credits are all about sourcing. So the other problem that I have with these rating systems is they have this pick and mix approach, and so you can orchestrate a high rating without doing well on materials or on energy at all. Now, I'm not saying that these rating systems are all bad. They've obviously set a benchmark where none existed before. But what I am saying is that I think we can improve them a lot. And for energy, I think what we should do is take the passive house approach. I'm not necessarily saying we should set targets that are as strict as passive house, but the way they assess energy is on primary energy use over the year, and then on peak energy demand, which is something that Dave Richards advocated in his breakfast talk earlier in the year. Now, while I really like what Passive House does on energy, the one thing missing is they just focus on energy. They ignore materials. So if I was to make up a rating system for London, for instance, I would set about half of our effort on energy and using a sort of passive house assessment, but maybe not quite so strict. And then 35 to materials, but equally split between sourcing on the one hand and efficiency, material efficiency on the other hand. And then I think it is important to consider water, site and ecology, waste, but I think it's also very important to recognise that if we want to do something for the environment and for ecology, we need to go back to the planetary impacts, and material sourcing and our energy use has a much greater impact on ecology than the site where we're building. Now, saving energy. How can we do that? You know, the first thing we've got to do is go back to O.'s principle about cost. You know, we want to save energy in the most cost-effective way, in my opinion. And I think it's quite simple, really. We need to improve the performance of facades. Now, facades, while they can have quadruple glazed windows with interstitial blinds, the heat lost and gained through such a window is still going to be more than through a regular wall. So I think the main thing that the architects can do is to really consider how facades are designed and optimise the glazing areas, really considering the energy penalty paid for our large glass facades. Now, I'm not advocating that we live in bunkers or go back to celebrating the idea of the sort of 1930s windowless office, which the air conditioning company York was obviously very excited about at the time. What I believe is that we should keep these simple environmental ideas in mind of energy saving and material efficiency, and continue to design buildings that meet diverse human needs. We need factories and offices that support successful business. We need homes to raise healthy children in. And of course, we need museums and sports grounds and opera houses to celebrate our culture and art. Now, while I'm very against the idea of spending a lot of money on on-site Eco-Bling, I do think the construction industry should make a direct contribution to Offsite Virtuous Energy. Now, I think we can do that with a simple financial mechanism called an energy fund. Basically, buildings would be assessed against their energy performance, and then the buildings who perform best might even be exempt, but all other buildings would contribute to a fund which would then be spent on infrastructure upgrades or large-scale renewables. Now, this idea of an energy fund is actually already considered as an allowable solution for the Code for Sustainable Homes, but it's seen as a sort of allowable solution of last resort. Now, I believe that now is the time to make this our solution of choice. We should ask the GLA to set up a fund that all London developers could invest in if the energy performance of their buildings required it. And then that money could be spent on adding carbon capture and storage to the power stations that already supply our cities. And it could also be invested in the wind farm already called the London Array. Now, what I love about this solution is it would slash our carbon footprint without costing the Earth. Thank you. Questions, anyone?
You talk about large-scale offshore wind as being your preferred solution. Why do you say that rather than anything else?
For the UK, again, using David Mackay's book as a sort of source, all of the other renewable systems can't make a significant contribution. There's not capacity for them to do so. And onshore and offshore wind, onshore's obviously cheaper, but there's a real resistance against it because of people not liking it in their backyards. And so I think we can afford offshore wind because offshore wind in the UK is actually cheaper than onshore wind in Spain. Yeah.
And what about going outside?
Well, carbon capture.
Boundaries.
Right.
I guess that's the...
Yeah, so outside of the UK, if you went to Spain, for instance, solar is a good idea, and it will become an increasingly good idea as the technology gets cheaper. But it will always be later in the future that it becomes cost-effective in less sunny climates. That's my view. Yeah. At the back in the middle.
If I understood your sort of central argument correctly, it's really about rediverting the money which is currently spent on individual construction projects to do something sustainable and renewable. Have you managed to get any figures in terms of if you took what had been spent, on London projects to achieve planning regulations, if you were to divert that, say, over a 5-year period, what that would sort of equate to in this sort of combined infrastructure?
Yeah.
Is it a meaningful investment that actually could make a difference?
The one thing that I can say is that the difference between on-site and off-site is multiples of an increase in capacity. And it's directly reflected by the feed-in tariff structure. We have a feed-in tariff that is much higher for on-site systems because if we didn't, people wouldn't install them. And there's a lot of work being done in DEC to define those bands, and that gives you a direct reflection of the real costs from all that financial analysis that's gone in to set the tariffs. Yes?
Yeah, I believe a lot of the issue is to do with personal behaviour.
Yeah.
Because we don't actually, or we're unable to relate our action to impact at the moment, because we can't. Do you think that taking a large off-site strategy helps that, or doesn't? I can see it not helping that debate, because it almost makes the problem so far away that you don't need to touch it, and therefore it will fine again. I think actually the on-site strategy, albeit I understand the cost issue with it, does change behaviour because you can see it immediately. Yeah,
so that's a really strong reason to have the on-site systems, this idea of inspiration, the idea of it being visible. The concern that I have for anyone who's not actually informed, they see it as a solution. So I think that it actually flips the other way. They see the energy systems and say, oh, great, well, the buildings have sorted it out. And so we're back to the same position that you were concerned about, while having wasted some money. That's the way I see it. Oh, thank you very much.
I've thoroughly enjoyed it. It was really engaging, very well delivered, and some really interesting topics that have been around for a while now, that are kind of gaining ground in kind of lots of thinking. But until something changes on the kind of regulatory side and government side and building regulations planning, it's kind of tantalising, but we can't see it happening. But it's an idea that we've had in our practice for many years. This would be a great thing to do. So it's good to see other people kind of pushing the boundaries and seeing what can happen.
Well, as always with these morning talks, they're very thought-provoking, and this one in particular was very good. The point of view expressed, I thought, was very good, and for me personally, with some of the work that I've been involved in, it had a lot of resonance, particularly with the kind of systems that we're putting in on buildings in London, which, to be quite frank, they are bling, and they're not going to make a significant contribution, and that money could be better spent. And I think that was the point that I take away with me, apart from the wider thinking about the planet in general and where we sit in the whole systemic approach to energy. So for me, a great thought-provoking morning.
I thought he got it right in terms of what we need to do is design buildings that are much more energy efficient and not put glass everywhere. And I've been campaigning for the death of the glass box for many years. So I was really interested to see the image he used of the windowless office building in America, which I thought was terrific. I asked him for a copy of that because I thought it was really good to help my campaign. So it was very good.